Hey there, this is Horner, and we're going to take a look at the AP Physics 1. It could be for AP Physics 2 or even AP Physics C, Mechanics or E&M, and it is a lab template. And we're going to use the D-square acronym, so diagram, setup, quantities, apparatus, repeated variable, and error reduction. We've also added an analysis section to this document. So students will go in and put in the obvious things, and then they really need to put in some sort of objective, or, what is their hypothesis? What are we looking for? What are we trying to figure out? So a lot of times that's something that can be done at the very end of the experiment. If it's an inquiry question that they're given, they can just write it there. This is a great space for them to go ahead and draw that diagram and then also put in the setup. Remember, in the setup, we're just trying to say whatever the picture doesn't say. There's 4 boxes for them to go through, or 4 columns for them to go through and give the quantity and the apparatus. So far we've done the S, the D, S, Q, U, and A. So those things are all done. Once they've done that, we give them plenty of places to put data. So it might be that they do trial 1, trial 2, trial 3. They put an average here. They might put something else over on this side, but there's plenty of boxes for them to do that. We also want them to tell specifically what that repeated variable is, or what that independent variable is, and then give a little bit of information as to how they're going to reduce error. And 99% of the time they can just say that they're going to run multiple trials and then average those trials. For times when they need to linearize data, we did provide 2 graphs on this document, and on top of that we also have a place to plot that final data. So it might be that they do 3 trials, they have data here and data here, they plot these 2 columns, they get anything other than a straight line, and they have to go back and linearize. So now they would use this area to linearize and use the bottom graph in order to draw that linear graph. Always make sure that your students are adding the label as well as the unit on the Y and on the X-axis. Title is not needed for this, but if you want to do that because you feel like it's a good way to teach them how to create a proper graph, that's fine. Just points are not given for that on the AP exam. So same thing on the bottom one here. Slope determination, most of the time when you have a straight line that they've been given, they've got to determine the slope, and they need to show their work. You can have them start with m equals delta y over delta x, or you could actually have them use the labels on each axis to do that. So it might be change in position over change in time. The physics equation is unique to this in that instead of just writing y is equal to maybe 5 times x plus 1, they would actually write the physics terms that are in the label. So instead of y is equal to 5x plus 1, they could do something similar to position is equal to 5 meters per second times time. The last part that they're going to do here is state how the analysis of the data might support the objective or the answer to the question, and they should use some sort of acronym. I know some people use claim evidence reasoning. Here I'm using basic physics, so they actually have to show some sort of equation or tell about a conceptual thing that they know in terms of physics. Cite evidence, typically from the graph or from any of the data, draw it together, and then finally answer the question. And that is what that experimental design template does for them.